So if we look at the evolution of DevOps as a quick opener, although the slide goes back to 1957, I'm going to say if we say agile development was the methodology that was predominant after the year 2000, 2001, agile itself, obviously a development of Scrum, which first appeared in the 80s, then DevOps is probably what's been on everybody's agenda for the last few years. And across the industry, across the software development industry, it's been rapidly embraced. And no doubt, like all of us, everybody who is going down that path is going through a huge retraining and resourcing exercise. Agile development's adoptions itself aim to speed up the development lifecycle and get new features and upgrades ready for release quickly, and moved away from the old practice of having annual or 6-monthly software releases to software packages and applications, to the concept of continuous innovation, continuous integration of that development in short cycles or sprints. Each sprint ideally would contain a fully releasable package that could be pushed out to your customers. And that's this agile approach. I think it's widely now the most common. It's taken over from waterfall in just about everywhere. And it's certainly led to developers being able to develop and release new features much quicker. However, on its own, it's not directly addressed the issue of how do you deploy the output of these sprints into production. It primarily focuses on the development lifecycle up to the release point. And if you have a large number of customers in your customer base who, excuse me, have their own priorities, then getting these new developments into production has always been a problem. And before the development of DevOps, quite often you'd find customers on different versions of your software and not necessarily all making it easy for you to support them all. Most of you will also remember when a new release could have often mean as much work as a full implementation to get it out there, and you definitely didn't want to be doing that every 3 weeks. So what DevOps seeks to do, and this is the universal sort of symbol that everybody uses for DevOps, is to keep this acceleration of the application and software program development, but combine it with the operational processes needed to get your new software tested and released, deployed and operating effectively with your customers. And that includes things like configuration. And it aims to do that effectively and efficiently. Okay, that's an oversimplification, but hopefully it conveys the essence of what we're talking about here. And that cycle, it's a continuous process of integrating new things. Acronym that we all bandy about. In our next webinar, we'll look at this in much more detail. We'll look at what the key elements are that you need to utilize to be successful in DevOps, and then how do you deploy DevOps within your organization, particularly in the Azure environment, and what tools, automation, pipelines, etc. are available to help you do this. So that will be the subject of the next webinar. But why is DevOps so popular? Well, I've listed some benefits down on the right-hand side of the slide, but basically it delivers on the promise of Agile, getting updates and new releases out to your customers faster, improving collaboration across the business by development and operations working together, obviously improves quality because you've got everybody's requirements built in from day one. That means there should be less downtime when you do an update, less update failures, less rollback, and of higher customer satisfaction should result from that. If you do have an issue, then working together to troubleshoot and problem solve should avoid finger pointing and make resolution times a lot quicker. So ultimately, what you're aiming to get out of DevOps is preserve that agile speed of development and getting things ready to go to market, but actually getting them out there with better quality, quicker, and with less operational support problems going forward. just about every software business knows that you don't necessarily have to be first to market with your new features or new products, but you do need to be fast. And DevOps seeks to deliver that in a cost-effective way. Of course, public cloud systems and the applications and software delivered via them, particularly if they're delivered as a service rather than in the traditional license model, have completely changed the financial models that we all have to operate under. The cloud in particular, and the principle of pay as you go, paying for what we use, has seen a major shift away from CapEx based control of IT spending to OpEx based models. This has changed the way the whole business operates. The role of procurement has changed for buyers. Pricing is very different for vendors and suppliers. Commission models change for sellers, and investment plans and return on investment is on a different basis. All of these things have become to, under the DevOps umbrella, have become to be named as financial operations or FinOps, which is an approach fundamentally to addressing these changes across the business. Excuse me. What it's looking to do is make sure you've got visibility, you know what your costs are at every step of the software development life cycle, as you see on the right, and you know how those costs have been incurred and where they should be allocated if that's what you want to do. Applied correctly, it should allow you to track those costs to single actions in your product life cycle. It then gives you tools and an approach for optimizing those costs in the operational environment and continually improving those, or optimizing them even before it goes to operations, and then continually improving that on a cyclical basis. So it's kind of applied across the whole of the software development lifecycle as DevOps would see it, and is an integral part of adopting DevOps if you want to keep control of your costs and get the most from your investments. Much like DevOps, which spreads responsibility for getting your software out to your customers with new releases and new features as efficiently and fast as possible, then FinOps spreads that responsibility again across the whole business. Design decisions, for example, have key implications for cloud operational costs later on. Release pipelines will reduce upgrade costs, and cloud cost management has many tools and approaches in it, such as serverless architectures to control costs. Tracking those costs using tagging and other tools that the various vendors support will give you clear visibility of where you're incurring those costs. In larger organizations, there are separate FinOps departments, but most of us are also investing in FinOps skills among our developers. New KPIs are being introduced around cost control and optimization that didn't really exist before in the old CapEx world. Of course, just adding new stakeholders in terms of these FinOps team members on its own will not address this. In the public cloud, developers and architects can easily deploy resources on demand, particularly as a quick fix if they look at it from a cost point of view, things like reserve instances or committed use discounts can be much more cost effective. But typically they haven't had that responsibility in the past, so they haven't necessarily seen the need to do it. If we don't want to lose the speed and agility of DevOps and the agile methodology that we use in development, we need to empower and train our engineers to understand where these costs make the difference and make those decisions themselves, rather than have to go to a gatekeeper who helps them through that. So in the same way that security has shifted to become much more of a developer responsibility, and we'll talk about that under the DevSecOps in a moment, so financial responsibility is also moving that way. In the second of our webinars that comes after this, we'll explore the FinOps principles, what their impact has on business planning, and look how you can implement them when using Azure Cloud, using policies and all the other tools that are available within the overall Azure DevOps stack. Understanding cloud costs, how to manage them, and keeping up to date with the changing models that the various vendors are introduced as the market matures is a key skill, and one that we're all going to have to learn. Some of the key issues that we're all facing include getting our developing engineers to understand and take that responsibility in the first place, as I've already said. How do we actually deal with shared costs? A lot of these environments are shared environments or have shared elements. So how do we share that across our customer base and build it into our pricing models? And what does this all mean for our revenue and cost forecasting and budgeting? So in simple terms, we've got to train all our architects and engineers to understand FinOps and the role that they play in helping control costs and get the most from your investments. The FinOps specialists themselves need to realize they're primarily there to support the developers, not police them. I would recommend you lean on your managed service provider or your cloud providers and use their expertise. They've been doing this probably a lot longer with more customers than you and come across many more situations. And of course, are incentivized to keep up to date with all the latest offers and models that can maximize your return. And finally, I'd say don't overcomplicate things. Don't try and invent tools for yourself. There are lots already there that you can use. So you, and I personally think that by and large, they should suffice. I'm also old enough to have been around for a long time with legacy applications when I was selling software as a licensed product on perpetual license basis for on-prem installation or data centers. And trying to make sure they were compliant with the various security standards and regulations was always something that tended to be done after we'd developed the software itself. So it was always very much an add-on and probably a lot simpler because they weren't in a public cloud and weren't anywhere near as accessible as things can be if they're excuse me, if they're promoted wrongly in the cloud. Unless your software is completely cloud native, then it's not usually been designed to allow for this type of access via the public cloud. And of course, with today's environment and the ever-evolving threats we all face, the one responsibility your customers are going to point towards you is around the security, not just of your software, the data it stores, but the whole stack that your application sits on, particularly if you're delivering this as software as a service. So you're going to be responsible for the security of that complete stack and all of the threats, monitoring and addressing them that attack that. The only thing we know for sure is that everybody suffers from attacks of one sort or another and will continue to do so, and they have been increasing. The financial hardships of recent times have seen a sharp uptick in this type of activity, ransomware, etc. It's impossible to mitigate it all, it's just not practical, and it's too expensive for one organization to do that. However, there's no point in sticking your head in the sand and pretending it's not your problem either, because that's not going to stop it happening. In response, you can implement all sorts of policies that will certainly help prevent attacks and protect you from the most common things, and then they'll help mitigate and remediate if you do get attacked. And things like zero trust policies that you'll have heard various people talking about are one area that there's been a big focus on in recent times. It's not the complete story. It tends to focus more on endpoint protection than the complete software development lifecycle. Things like zero trust has largely ignored the need to secure applications from the point they were developed rather than from the point they're deployed. Google themselves have led the move in this area, and they put it as shifting security to the left. In other words, if you look at the DevOps diagram, pushing it more from the operational side of the business into the development side of the business as well. Excuse me. That's very much the same argument that we would use for FinOps as well. So DevSecOps, or Development Security and Operations, aims to make security a key part of the complete development, deployment and operation lifecycle of your software. It makes security a shared responsibility again, and your security team of specialists, much like your FinOps specialists, are there to help implement and support security initiatives across the board rather than police them or act as gatekeepers that have to be got past to be able to get things into production. By integrating security into your whole software development lifecycle from build to production, it bakes that security in and shouldn't slow down the cadence of your delivery velocity, whereas gateways typically do. This is easier and much less costly than catching vulnerabilities after you've deployed software and fixing them once they're already gone into production. And of course, the benefit to your customers is less disruption and patching and a much better service. Again, I don't think this is just a deployment of tools and the right thinking. I think this is a culture shift alongside the whole DevOps and FinOps in the way that we have traditionally looked at the software development lifecycle. We need to foster in security in particular the mindset where people start to think, well, when do I need to be doing this? Not which tools do I need to use or what do I need, what security do I need to apply? Once you know within that software development lifecycle where you think you should be applying security, then clearly it's time to get on and do it and look at what tools you need to do. And there are many of these available for you. So if you look at well, things like pre-commit security scans, they can be built into your pipelines, they can be automated. You can use techniques like static application security tests or software composition analysis, particularly if you're using shareware and stuff like that. And there are many things that you can build into your pipelines and release cycles that you can do automatically. In our DevSecOps webinar, we'll explore these principles further, look at these tools and how you can implement them in the SDLC, particularly with note to the Azure cloud. And we'll give some examples of these. So I hope this short introduction has given you an overview of the ops, if you like, and how they all fit together. Most people, as I say, would say they constitute a culture shift rather than just methodologies. And this ability to be able to continuously deliver and operate safe, secure, performant and function-rich solutions for your customers will allow you to deliver value to them and to yourself and get the best return on your investment. That's probably all I want to say now. I don't want to steal the thunder of the guys doing the other webinars, but thank you very much for attending. I hope this short introduction has helped. And if you want to go deeper into the topics that we've raised today, then these are the dates of the 3 follow-up webinars, and please book yourself in and attend them. That's all for now. As I say, post any questions you've got and we will get back to you on that on the chat. Thank you very much.